and welcome to this session on making snap gauge. Let us begin with this session.
Let us look at the objectives of this session. At the end of the session, you will be able to rough file to overall size as per drawing, mark the profile as per drawing, chain drill, chip and finish file the snap gauge profile as per the drawing. Turn a cylindrically round workpiece to size and shape as per drawing. Check the turned rod using finished snap gauge. Gauges are scale-less inspection tools used to check the dimensions of the parts. They do not determine actual size or dimension of a part as per measuring devices like micrometer or vernier caliper does. Gauges can be broadly classified as standard gauges and limit gauges. Standard gauges are exact copy of mating part of the component to be checked. Limit gauges are used to check whether the inserted part is within the specified limits. The limit gauges are used to segregate acceptable and non-acceptable products in mass production without exact dimensions. The advantages of a limit gauge are as follows. Using limit gauges to inspect parts is faster than measuring them directly. Limit gauges are used in mass production for checking and controlling various dimensions. Semi-skilled operators can easily use limit gauges. A well-designed limit gauge can check both linear and geometric dimensions simultaneously. During mass production, usage of limit gauges reduces the cost of measuring in comparison to measuring instruments. The most common types of limit gauges are plug gauges, ring gauges, snap gauges, combined gauges, screw pitch or thread gauges, template and form gauges, taper gauges, feeler gauges, position gauges. Snap gauges, also called as gap gauges, are metrology tools used to gauge the diameter or thickness of a part to be within certain limits. Snap gauges are generally C or U-shaped. Snap gauges can be further classified as rip type snap gauge, also called as solid snap gauges, double-ended type, single-ended progressive. Plate type snap gauge, also called as gap gauges, double-ended type, single-ended progressive. Adjustable snap gauges, combined limit snap gauges, thread snap or thread caliper gauges. Let us learn the procedure to make a fixed limit snap gauge to gauge ton plus or minus 0.02 mm shaft. The tools and equipment required are surface table, angle plate, marking media, height gauge, divider, center and dot punch, ball peen hammer, anvil, drilling machine with required size drill bit for chain drilling, web or flat chisel, sledge hammer, flat, round and half round files of different core sizes, steel rule, tri-square, vernier caliper. Check the raw material for its size using a steel rule. Rough file all the 6 faces of the rectangular workpiece using a bastard file. Ensure the flatness and squareness using a tri-square. Apply marking media evenly on face A of the workpiece as shown. Mark the workpiece to 75 into 48 into 9 mm as shown using the height gauge. Witness mark the lines drawn using dot punch and ball peen hammer. File the workpiece using smooth file to maintain the 75 mm into 48 mm into 9 mm. Ensure the dimensions using vernier caliper. Check the squareness and the flatness of the workpiece using a tri-square. Again, apply the marking media on face A of the workpiece. Mark parallel lines at 6 mm, 17.01 mm, 19.01 mm, 24 mm, 28.99 mm, 30.99 mm and 42 mm from face B at the no-go end using the height gauge as per the drawing. Mark parallel lines at 6 mm, 16.99 mm, 18.99 mm, 24 mm, 29.01 mm, 31.01 mm and 42 mm from face B at the go end using the height gauge as per the drawing. Mark parallel lines at 6 mm, 15 mm, 21 mm, 49 mm, 55 mm and 69 mm from face C using the height gauge as per the drawing. Witness mark all arc centers using center punches along with ball peen hammer. Mark radius 6 mm arcs at given locations as per the drawing using a divider. Mark radius 15 mm arc at given locations as per the drawing using a divider. Witness mark all the profile lines using dot punch and ball peen hammer. Chain drill the profile as per the drawing. Perform sawing operation to remove the excess material using a hacksaw. Now remove the excess material by chipping. File and finish the profile using smooth or dead smooth file as per the drawing. Check the dimensions using a vernier caliper. Finish surfaces and remove burrs. Let us now learn the procedure to make a 10 plus or minus 0.02 mm shaft. Tools and equipments required are lathe, vernier caliper, single point cutting tool. Check the length of the workpiece using a steel rule. Hold the cylindrical workpiece in a center lathe with a universal 3-jaw chuck. perform facing operation to maintain the length at 60 mm. Plane turn the cylindrical workpiece to a size of 10 plus or minus 0.02 mm, maintaining the dimension between 10.02 to 9.98 mm. Perform a chamfer of 2 mm by 45 degrees at both ends of the workpiece. Check the turn shaft using the fixed limit snap gauge. If the workpiece enters go side and does not enter into no-go side, it means the turned component is accepted and dimensions are within the limits. If the turned component enters into both go and the no-go end, it means the turned component is not accepted and the turned component is undersized than the requirement. If the turned component does not enter into both go and no-go end, it means the turned component is not accepted and the turned component is oversized than the requirement. Apply thin coat of oil to preserve it for evaluation.
To recap, we have learned to rough file to overall size as per drawing, mark the profile as per drawing, chain drill, chip and finish file the snap gauge profile as per drawing, turn a cylindrically round workpiece to size and shape as per drawing, check the turned rod using finished snap gauge. So that's all about making snap gauge. Hope you have understood all the concepts and exercises. See you in the next session.